We continue with the linear motion. In this tutorial, we're going to look at the equations that govern linear motion. Now, I have to mention that when we are talking about linear motion, we are talking about the object that is moving in a straight line and on a flat surface. This is differentiated from motion due to gravity. We're going to talk about that later. It is also differentiated from angular motion, which is the motion around a fixed point. It is also distinguished from projectile motion. So when we talk about linear motion or rectilinear motion, we are talking about an object moving in a straight path on a horizontal surface. That is what we mean by linear motion in this case. Okay, so there are three most important equations that govern linear motion. Number one is velocity is equal to u plus at. Okay, now v is simply final velocity, which is measured in meters per second. U is the initial velocity also measured in meters per second squared. A is the acceleration. We have already defined this, and the t is the time interval. Okay. Now, it's very important for us to understand what final velocity and initial velocity is. So, if a car starts moving from 0 meters per second, and then you travel all the way, increases its velocity up to maybe 10 meters per second. So, it starts, let's say, at 0 meters per second. Then it goes all the way to 10 meters per second. Now, the velocity with which a car starts with is what we call initial velocity, represented by the letter u. Then the velocity, the later velocity at which it reaches is what we call the final velocity. So it's very important for you to understand what initial and final velocity are. Okay, now this equation sometimes is written as acceleration is equal to final velocity over time. It's the same equation. It's only that in this one we first of all make final velocity the capital of the equation, so to say. So this one and this one are the same equation. Don't get mixed up. Then we have got AC, which is equal to S is equal to UT plus half at squared. So let me say this is equation 1, this is equation 2. Now, this is the distance that is covered. Initial velocity multiplied by time plus half acceleration multiplied by time squared. Very important equation. The last equation that we are going to look at is v squared is equal to u squared plus 2as, equation number 3. Okay, so you have got final velocity squared is equal to initial velocity squared plus 2 acceleration multiplied by distance. Now, when you are given a question, run to these three equations. Of course, there's a fourth one. Maybe we can look at it later, which is maybe just for the sake of writing it. We say distance is equal to initial velocity plus final velocity over time, something like that. So you can always look at it. U plus v is equal to, this is for average velocity. If you want to get average velocity, you use this one. This is point number 4. You can use this for average velocity, but that is not our major concentration in this tutorial. Okay, so you have got that one, this one, and that one. These are the ones that I want you to focus on. Now, when you are given a question, it's very important for you to first of all collect data. When you collect data, it will help you to know which equation you are going to use. Because, for example, you cannot use this equation if you are not given acceleration. Neither can you use this, neither can you use this. You get it? If you are not given time, you can't use this, you can't use this. But you can use this because this one doesn't have time. If you are not given distance, and you are required to find the end of this, you can't use this, you can't use this, because these require you to have distance. In the similar case, if you are not given final velocity, you can't use this. You can only use this. So first of all, look at the question that you have been given, collect the data that you have been given, then look at these equations and ask yourself, with the information that I've been given, which of these equations can I use? That will help you. See you in the next tutorial.